This is the start of our lesson on section 7.4. You need to read pages 328 through 331. Our assignment is problems 1 through 8 all, 9 through 19 odd. You'll see that on 9 through 19 a lot of them have 5, maybe 6 parts to them. Okay, when you read it, I want to make sure on page 328, I want you to read closely. It says an example of a sampling distribution about the middle of the page until about the middle of the page on 329. You have the beige box there with some formulas in it. Read that closely. I'm going to talk about that some more in a minute. There is something, if I can find my formula sheet. I want you to take your formula sheet and when you get down we're in chapter 7 where it says standard deviation of sample proportion, and this I already have written in there that the mean of p hat is equal to p. Of course, the other was typed in there. I want you to add what I have in red here. NP is equal to or greater than 10. N times 1 minus p is equal to or greater than 10. That tells you got to have numbers equal to or greater than 10 for both of those in order for the this program, in order for the central limit theorem for proportions to work. All right, on page 328, as you look closely at the table that's given there, they're talking about flipping a coin 5 times. So if you flip the coin 5 times, now we're going to get some ends that are tremendously larger than 5. In other words, what we're doing is going to shorten things that would take a week to work into a matter where you can work them in a matter of minutes. But if I were to flip a coin 5 times, the number of possible outcomes would be 2 to the 5th. In other words, first time I flipped it, there's 2 outcomes. Next time I flipped it, 2 outcomes. Next time I flipped it, next time I flip it, next time I flip it. When I flipped it 5 times, that's got 2 to the 5th, or there's 32 different ways that this thing could come up. Now, what they've done there on at table 7.2 is that they've given you a sample space for the 32 ways that the heads and tails could come up on a coin. For p hat, which is what we're going to be working with, for p hat they give you the part what part of it came up heads. For example, if they all came up tails, you had no heads, so p hat would be 0. The next one they give you there, you had 4 tails and then you had a head. 1/5 is 0.2, so p hat is 0.2. Look on down to the 4th one. They have 3 tails and 2 heads. That means 2 out of 5. 2 out of 5 is 0.4. So the p hat is the proportion that on each of the 5 times you flipped a coin that you came up the number of heads out of the 5. And so that's what we're going to be working with. That's an example. Now, want you to, what's neat about this is that if we can figure out what the mean is. Let me say one other thing before I go there. I want you to go ahead and look at their example on page 331. And if you notice, they go down and figure what z is. On the previous section, we were able to work the problems without z. We're going to be using the same app on our calculator to work it if we figure z and if we don't figure z. So we can work it without figuring z, so when we work these, even though we know how to calculate the z-score, we're not going to because we don't have to. And you'll see that when I get to it. Let's go ahead and they show you there how to find the mean of p hat back on page 328, 329. They show you how to find the mean of p hat and how to find the standard deviation of p hat, and we're going to be using that, and we're going to be figuring that quite a few times. Now, right now, I want you to look at number 1. Number one is on page 329. Okay, they want me to find the mean of p hat, and they want me to find the standard deviation of p hat. Now, we just showed on our formula sheet that the mean of p hat is the same thing as p. Since p is 0.82, we see that the mean of p hat is equal to 0.82. They tell us that the standard deviation of p hat is the square root of p times 1 minus p over n. So we take the proportion of p, which is 0.82, and we multiply it by 1 minus p, which would be 0.18, and we divide it by n, which in this case is 20. Now, 20 is a whole lot more than the 5 that we were working with on flipping the coin. Now, what's going to happen is when we actually start working these problems and we're finding the probability that p hat is less than 0.6 or p hat is greater than 0.85 or something to that effect, when we plug in for the standard deviation of p hat, we're going to plug this in and not the answer that we're going to get now. But they're asking for this, and they want us to go ahead and work it out. So let me get my calculator. And for this problem, we're going to go ahead and work it out. So I see that I got second square root, and we're going to go green n over d. We're going to hit enter. I see that the n on this is going to be 0.82 times 0.18. Then we're going to arrow down and we're going to plug in the 20 and we're going to hit enter. And we see that this is 0.0859 and so forth. So we've figured out on those how to find the mean of p hat and also how to find the standard deviation of p hat. I now want you to go to problem number 11. And 11 is on page 332. They tell me in 11 that n is equal to 270, that p is equal to 0.57, and they want me to find the probability that p hat is greater than 0.61. Now, basically what that's doing, if I do my standard normal curve, and they want to know the probability, and we're doing this is the p hat, we want to do the probability that we're greater than 0.61. In other words, put that in the wrong place, excuse me. The 0.61, we want to know greater than, we want to know what that area is right there under the curve. Okay? So, we're going to take our, we're going to find the mean of p hat, and we're going to find the standard deviation of p hat, and then we're going to use normal CDF on our calculator in order to find this area in here. So the mean of p hat is the same as p, so that's 0.57. The standard deviation of p hat is the square root of p, which is 0.57. Now you can look at this on your, you're going to have memorized very shortly, but you can look at this on your formula sheet, times 1 minus 0.57, which would be 0.43, divided by n, which is 270. Now, as I told you before, I can figure this and plug it in, but I don't have to. I can leave it like this, and I can actually plug it into my calculator like that. So let's go to our calculator. And again, I could do like they did on one of the problems that, or two of the problems that they gave as examples. I can find z. If I found z, I would use a standard deviation of 1, and I would use a mean of 0, and that would work when I'm finding z. With using exactly the same program, I don't have to do that. I can go ahead and work straight through using this, and using this for my lower and a big number for my greater. All right, let's go. We're going to go second distribution. We're coming down to number 2, normal CDF. It asks for the lower. The lower in this case is 0.61. It asks for the upper. Now, upper, I just want a tremendously large number sitting out there. I'm going to plug in 100,000. That ought to be plenty large for the size numbers we're using. Wants to know the mean. That's, in this case, that means the mean of p hat, not the original mean, but the mean of p hat, which is 0.57. And then they want to know the standard deviation. Now, a little bit of a hang up right here. Now, we did this before. We went second square root, and then we went up and we did n over d. If you do n over d now, it's going to give you a little slash sign, and it's not going to work, so we're going to have to use parentheses to put that in there. So I've got, when I go to the standard deviation of p hat, which on here is going to be the standard deviation of just the standard deviation. So I go second square root. I'm going to open up parentheses. I'm going to put this in divided by that. So I open parentheses, and I've got, see if you can see this, I've got 0.57 times 0.43. I'm going to close the parentheses, and then I'm going to divide by 270, and I'm going to close the parentheses for the whole thing. So my standard deviation of p hat, I'll plug it in like so. All right, so I'm going to hit enter, 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 and I come up with an answer of 0.09215 and so forth. So the probability that p hat is greater than 0.61 is this thing right here. Okay, I now want you to, let's go to problem 17. And let's give the information on 17. Student Institute, the Institute of College Access and Success reported that 68% of the students, so P is going to be 0.68, 0.68% of the students in a recent year graduated with student loan debt. A random sample of 85, so N is going to be 85. Graduates is drawn. First part is A part is to find the mean of P hat. Now remember, we said that the mean of P hat was equal to P, and P in this case is 0.68, so we like A. You'd probably like to see that on your final exam, would you not? So we've got P hat is 0.68 for B. Okay, for A, excuse me. Now let's do B. On B, they're asking for the standard deviation of P hat. Now, by this time, you probably remember that the standard deviation is going to be the square root of P times 1 minus P over N. So in this case, this would be the square root of P, which would be 0.68, times 1 minus P, which would be 0.32, divided by N, which is 85. Now, since they're asking us to give that number, this we're going to work out. Now remember, when we use it later, we probably won't work it all the way out because our answer will be more exact if we don't, but for right now we will. So we're going to go second square root, and then we're going to go N over D, and we're going to go 0.68 times 0.32, and then we're going to arrow down, and we're going to say 85, and we're going to hit enter, and we get 0.050596 and a whole bunch of numbers after that. Okay? Let's do C. Now, I'm going to leave this part up here. And on C it says, find the probability that less than 60%, so the probability that P hat is less than 0.60 or 0.6, the people in the sample were in debt. Okay, so when we do this thing, we're going to go to second distribution. Now, every once in a while, just 7.1 your calculator and you get to start all over, but we're okay. You don't have to. Second distribution. We're going to go down to normal CDF. I'm going to hit enter. Now, this time it's lower. I'm less than 0.6. Now, I can plug in a small number like -1 million. That'll work. If I had 7.12, my calculator would start off with a number. Let's just all do that right now to make sure we understand what I'm saying. Let's go second memory 7.12. That cleared everything on our calculator. And then we're going to go second distribution, just like what we were. And when I go down to normal CDF, I look and I see that they've got -1 times 10 to the 99th power. That is about as small a number as you're going to run into. All right, so that's our lower. Our upper is 0.6. Let me go back again. I done messed up again. I started plugging into lower. Let me give a small number there. All right, I got me a small number there. Upper 0.6. Standard deviation. Now, if I had been doing Z, I'd have to work on this a little bit. Don't have to. So what I'm going to do now, I'm going to go at my mean, and my mean on this thing, I guess I erased it, but my mean is 0.68. The mean of P hat is P, which is 0.68. So we plug in 0.68. And then we come on down to the standard deviation, which we just did. Now, we could have plugged in the number that we had a while ago, but instead we're going to plug this in right here. So I'm going to go second square root. And I'm going to have to open parentheses again because it's not going to work it for me using N over D. So I've got, for my numerator, after I open my second set of parentheses, for my numerator I have 0.68 times 0.32. I'm going to close parentheses. I'm going to divide it by 85. I'm going to close parentheses again. And then I'm going to hit enter until I get my answer. And I see that my answer right here is 0.056923 and so forth. Okay, let's go down to D. And I'm going to leave this part up here. And we go down to D on 17. It says find the probability that we are between 0.65 and 0.8. Find the probability that, write these down, that was 0.65 and 0.8. 0.65, 0.8. We want to know the probability that P hat is between 0.65 and 0.8. Now, we're going to do exactly the same thing again. We're going to go to second distribution. We're going to come down to normal CDF. We're going to hit enter. Lower on this thing this time is 0.65, so we're going to plug in 0.65. Our upper is 0.8, so we're going to plug in 0.8. The mean is exactly like what it was a while ago. If we cleared our calculator, we'd put the 0.68 in there for mean. The standard deviation is exactly like what we had a while ago. If we've erased our calculator, we would plug that in there again. And we're going to hit enter a few times until we get our answer. And we see our answer would be 0.7145 and so forth. What that is saying is, if I've got P between 0.65 and 0.8, The area in here is 0.7165. I've got my P hat between these two. My area in there is that. That's what we're saying. Okay, let's see what else we got here. We got to go down to E. It says find the probability that more than 75% of the people were in debt. Okay. We're doing the probability that P hat is greater than what did it say again? 75% that P hat is greater than 0.75. Again, we're going to do the same thing. I know I'm getting redundant. It may be boring you a little now, but we're going to do it anyway. So I'm going to go second, distribution. I'm going down to normal, CDF. The lower in this case is 0.75. The upper in this case, we're just going to pick us a big number. I'm going to plug in like 1,000,000 or something. And then the means stayed the same, 0.68. Standard deviation stayed the same right here. So we're going to hit enter, enter. And when I get through hitting enter, I'm getting 0.083256 and a bunch of numbers after that. Okay. Look down at F. It says, what would it be unusual if less than 65% of the people in the sample were in debt? Now, we're going to do the same thing and find the probability on it. And this time it says that P hat is less than 0.65. Now, again, I know we're being redundant, but we're going to do it again. We're going to go back and we're going to go second, distribution. We're going to go down to normal, CDF. This time we're going to plug 0.65 in there for our lower. And for our upper, we picked a big number a while ago. Let's just leave it in there. Let's go all the way down and we hit enter. We hit enter and we get 0.72338. And it said less than, excuse me. I wrote the problem wrong. I should have put less than. Hope I haven't messed you up on this. Okay, we're going to do it the same way. The only difference is that we've got less than 0.65. So let's go back and plug this in. I apologize for what I'm doing would have worked just fine if they'd have said greater than. They didn't. They're saying less than. So we're going to go back in and we're going to do it again. We're going to go second, distribution. We're going to normal CDF. The lower this time, we're going to put in a real small number. If I'd have 712'd, it would have been there. If I didn't, I'm going to plug in negative 1,000,000. The upper, in this case, is going to be 0.65. And the mean of P hat and the standard deviation of P hat stay the same. And when I hit enter a few times, I'm getting 0.2766. So the probability that we're lower than 0.65 is this. Now the question is, would it be unusual if less than 65% of the people in the sample were in debt? Would it be unusual? And the answer is, since it's 0.65, it would have been unusual if this right here had been like 0.05. 5% in here, this is 27.66%. So it would not be unusual for this to be the case because this is greater than that. Okay, work the problems. The problems, actually problems 9 through, what did we say we're going through, 19? 9 through 19, you're going to just continue doing almost the same thing over and over. Work enough of them so that you're going to remember how to do this when we get to the final. Guys, again, you guys take care of yourself. Wash your hands, use hand sanitizer, stay out of groups, don't be shaking hands with people, take care of yourself. And we'll talk to you with the next lesson.